We're going to start with a pan gesture handler. It will allow us to track the touch movements, and we're going to allow the max pointers of 1, so only 1 touch will be allowed on this view, which is an animated view from React Native Reanimated. The first thing that we'll need to do is set up a few animated values to hold on to the position that the user has dragged. So we're going to need to destructure value from animated. With our value, we can set up a drag x, which would be a new value, and we'll just initialize it with 0, and a drag y. We'll also need to hold on to some gesture state, and this will just allow us to trigger the drag whenever the pan gesture handler becomes active. So we'll say gesture state is equal to new value, and we'll just initialize it with -1, which is no particular gesture state. The pan gesture handler will always kick back new animated values based upon the delta translation of this particular circle that we'll be dragging. However, if we don't save off the accumulation of all those drags in an offset, whenever you go to touch on it, it will cause the circle to jump. And so we need to create an offset x, which we're going to set to a new value. And because we want to just start the circle in the center of the screen, we're going to use the width of the screen that we've pulled off here and say width divided by 2. And then the same goes for the offset y. We'll start it in the middle and say new value with height divided by 2. So finally, to capture the gesture state as well as the translation x and translation y, we're going to need to set up an onGesture event, which is equal to an event. And we'll use this array to say that we are receiving an array of arguments, and the first argument will be an object that we want to grab. That will have the structure of native event. And the pan gesture handler will kick back translation x, which will pass into our this.dragX, our translation y, which will pop into this.dragY, and then our state, which will pass into this.gesture state. The event call is from Reanimated, so we'll make sure that we import that and destructure that from animated. Then we can take this .onGesture event and we'll pass it into the onGesture event, as well as onHandler state change. The onGesture event will always fire, and the onHandler state change will only fire when the particular states have changed. Now that we have this all set up, we need to actually control what happens when the touch is initiated. And we're going to do that with a trans x, which will then be a conditional block from Reanimated. So because Reanimated is declarative, we need to pull off a few different actions so that we can declare how the animation should work. And they're going to be condition, equal, add, set, and then eventually interpolate. So now that we have those, we can take care of this, and so we'll say when the condition is met, and our condition will be whenever the gesture state is active. So let's dismiss this. We want to use the equality operator and say whenever this.gesture state is equal to state.active, and this state comes from the React Native gesture handler. It's just a helper to compare the actual states. Then, whenever that is the case, therefore the tap is active, this next argument will run. And what we want to do is say add this.offset x with this.dragX. And then whenever this the gesture state isn't active, what we want to do then is save off the particular offset drag x to the offset x. So we're going to use the set command and say we want to set this.offset x with add this.offset x and this.drag x. And the way that this works is that the final value that gets returned to this condition block will be applied to the trans x. So in our case, when we are active, the value being piped into the trans x, the translate x, is the offset plus the current drag state. However, when we are officially done and we've released, then we will pass in this dot offset x into the addition of offset x and drag x, which will then be our final position that we have dropped. So what that means is we can take this dot trans x, and for our animated view, we'll say transform, say translate x is equal to this dot trans x. And we'll do the same exact thing for the translate y. So rather than trans x, it'll be trans y. Here will be offset y, drag y, offset y, y, and y. Then we can take that and pass it into the translate y. So now if we refresh our simulator, we'll see that we are appearing right in the middle, and that's because the offset x and offset y have been set to the center point, and whenever this is not active, which it is not active, then we'll add the offset x or offset y with the drag y, so basically we're adding 0 to the center point. And now if we grab this and drag it around, we can see that it is following. We can stop, and our offset x and offset y will be updated with the current drag. Then we can do it again from the same exact point without jumping. Now we can control effects based upon the trans x and trans y. So we're going to also then pull in extrapolate, which will be working in conjunction with our interpolate. And we're going to set up two interpolations. The first is going to be the opacity. So we'll say opacity, and we're going to use our interpolate on this dot trans y. And so whenever we go any direction on the y-axis, we're going to trigger a new opacity. So we're going to take our input range, and because our input range runs from 0 to the height, we'll say 0 and height, and that will translate and interpolate it to an output range of 0.1 to 1. So when it's at 0 or close to it, it'll be 0.1 opacity, and when it's down here, we'll be at a full opacity. So we can take this and pass it into here and say opacity, this dot opacity. So now it's at a roughly 0.5 opacity, and as we drag it up, it'll get lighter, and down, it'll get more full. And finally, we'll add another effect which just controls the border width. So we'll say border width, and we'll then interpolate on the x, the translate x, say interpolate this dot trans x. Our input range will be 0 to the width, because as we go left or right, we want it to increase or decrease. Then our output range will have a border width of 0 or 5. And then we will use our extrapolate, which extrapolate dot clamp. And what that is going to do is not make sure that if we go any further, then it will never go past the 0 or 5 of the output range for our border width. So then we can now supply border width with this dot border width. See, it starts here. As we go left, it'll shrink down to 0. And as we go right, it will slowly grow, and we still have our opacity working.